Hi, I'm Nero. I wanted to try to do this weird thing. I don't know how it will go, but as I said in my previous video, I was thinking about doing a video where I show a bit of how I work, doing some coding, because I'm working on this code, this program that I use for doing simulations, physics simulations with particles. So, and I wanted to do some changes that I thought to improve it a little. So I thought that I could both like show the program itself, the kind of stuff I do, and also how I work on it, maybe, like because I want to do some changes. And I will probably like make a lot of cuts to try to go to the interesting parts. I don't know, this might be awful on the editing part, but I don't know. Um, let's see. I wanted to change the main part where it does the calculations. Here, here, here it is doing for every particle and every other particle because it's an n square simulation, and I have to do so this runs 2 times. The first time it will just calculate the acceleration. Yep, it just calculates the acceleration, and then the other time it will this, but I have to change it a bit so it calculates the precision that it needs to do, so it doesn't lose precision on the simulation. This is pretty hard to explain. Anyway, yeah, here goes again for every particle. So let's put here a second for loop. And I also thought that this could be a good way to, like, if you don't understand anything of what I do, like, well, I understand that this is a bit hard to explain, and if it's not your own code, you might not understand everything, but it's kind of a bit of a test. If you don't understand absolutely anything of what I'm doing, maybe you kinda shouldn't, like, start trash talking on the comments because you don't understand code, nor physics, nor maths, or anything. Maybe just let the professionals do their thing, but whatever. Yeah, here I do the check, so it's not the same particle. I will also need that. Alright. Will I need to calculate the distance? I think so. Just in case, I will copy it too. Alright. Then I did this only if the distance was, I guess, just in case. Like, I don't know exactly what I need. This checks if the distance is more than 0, so if by any case two particles are in the exact same position, it doesn't try to divide by 0. Yeah, here I get the properties of the second particle, which, well, of both particles actually, now that I see. I don't think I'll need this for the second part. Then it calculates the forces and puts it on acceleration of each particle, and then all of this has to go this second part. And yeah, here is I still have to do like a lot of tests to see which kind of forces I want to do, but these are the fundamental forces that I'm currently working with. I will do a video in the future explaining more about this one, but yeah, the fundamental forces, and this is how I think like physics actually work. and the best way to actually make a physical model and prediction for everything in the universe. Alright, and this is now the changed and like improved version where the acceleration is also taken into account, because I was like struggling in making so that it also worked with the acceleration. This is to make sure that the simulation goes as slow when it needs to maintain a good enough precision, and it works with the acceleration and the velocity of the particles against their distance of each other. And so like this, after the acceleration of each particle has been calculated with each other, then it does the double loop again to check the precision, and then finally I will need one more these loops to actually move them by the precision. This particle, the velocity is changed by the acceleration and with the precision, and then the position is changed by the velocity and the precision. The rest is just to control the simulation. Right, I think that's actually like all the change I wanted to do. Alright, now here is where I define the initial condition for whatever simulation I want to do. Let's see, I guess I can. Alright, I have 50 particles. I kinda want more, but there's the hard part, because you know your computer can only do so much. Now let's try 100. I wanted to do a simulation of a galaxy, so every particle is more or less the mass of a star, and their velocity are completely random. I don't wanna code, so they have some more or less circular motion, but maybe I should. Alright, I'll try to maybe make a code that kinda makes a better circular motion as initial condition. I'll try that, but this might take a little. Alright, I'm not sure, but this might do it. I'm not sure. I create a vector and I make the x and y scale on their position, so that way it should. Then I normalize and I scale the vector to the kind of values that make sense. I'm not sure, but this might work. I guess I can give it a try. Let's see. Alright, the simulation is done. I mean, I had it for a little bit, but I realized that I didn't like all three dimensions are on the same scale. The z dimension is also pretty big numbers, and to make something more similar to a galaxy, maybe I should have made this a lot closer to 0, but I don't know. Let's load the simulation, the recording, the simulation. This, this, and alright, this should be enough to load the simulation. This is the simulation, which seems that was a bit weird, like it does this, like from the side. You can see that it's like rotating. From here it is like rotating, but it seems that it is expanding and going outwards. A bit weird. It probably is because I gave it too much speed, like 100 particles with more or less the mass of a star. It's about 100 masses of a star, but I give it 100 kilometers per second, which is more or less like speeds on something like the Milky Way galaxy. Maybe that's a bit too fast, and it can't be contained. But overall, it kinda does its thing. I have to do a lot more testing. This is going backwards in time. Yeah, they are like, it's nice. Yeah, this is what I said, that like the z-axis should be closer to 0, so it's more like a disk and not this like cylinder. It's like a cylinder, rotating cylinder. Anyway, like the direction seems to be alright, right? Like the math I did to make a circular motion based on their position seems to be right. I wasn't sure of it. Alright, I will try to do another one. I will try to reduce the z-axis, and I will maybe I could even calculate, like, with this amount of mass, more or less what amount of speed. Good, I don't know. Alright, so this is the new parameters that I chose. I reduced the z-axis, so it's more like an actual galaxy, and I make the scale for the vector slower, so the velocity is slower. And let's try like this. Alright, simulation seems it was a bit weird. I don't know. Let's try and see how it looks. Alright, this is what I got. Yeah, you can see it is much more flat. It's like this. But yeah, because it is much slower, it didn't move as much. But maybe this looks like a better set of parameters that I could have for longer. I don't know, I still have to do a lot of tests. Anyway, that was it. I'll keep it like this, because this is probably still pretty hard to edit, because it's a weird format. So yeah, I'll try to just make sense of whatever I recorded. I guess this is it. Bye.